we're going to do our notes just a little bit differently today. We are starting Unit 3, so congratulations on making it through Unit 1 and 2 of Math 7. You are on to Unit 3, which is working with rational numbers. Specifically today, we are going to talk about just ordering and comparing fractions and decimals. Now, I did write review on there because it should be a review from 6th grade. It is going to be on a video today because I find that everyone comes in knowing different things about long division. So I really want you and encourage you to work at your own pace. So that means when you need to pause the video, if I'm going too fast, please feel free to pause the video, rewind the video. If you feel completely comfortable, you can pause the video and try to work ahead. Just make sure that you are checking your answers with mine on the We Tries. Alright, so here we go. Please make sure that you are following along, including everything that I am writing onto your notes so that it is complete and you can use it as a reference later on. You're getting all the practice that you can get. Here we go. Alright, so when we compare decimals, it is really important to remember to stack up your decimals or line up those decimals so that we're comparing our tens place with our tens place of each decimal and our hundredths place with our hundredths place. So for number 1, the first blank is line up your decimals by place value. Number 2, after you've lined up all your decimals by place value, you are going to add in any zeros to make the numbers equal in length. And I'll show you what that looks like in just a minute. And number 3, finally, you're going to compare values beginning with the tens place. So remember the tens place comes right after your ones place in the decimal. So this is your tenths, hundredths, and they have that th sound at the end, and that would be your thousandths. Okay, so here we go. For the first one, there should be enough room on the right-hand side of your page to write, to line up your decimals. So, what I mean by that is this. When I write my second one, I write my 0 directly underneath, and I line up that decimal. 0.25. So you can see all my decimals are in a nice row so that I can compare my tens place first. So we start up here with our tens place. So we have a 3, a 3, and a 2. Right off the bat, you can tell that that 2 is the smallest, so that's going to be my first decimal. If you get to your next place value, there is a hole behind the 0.3. So that's where we should have added our placeholder zeros. That way I can compare my hundredth place with 0.33 and 0.30. So the 0 is smaller than that 3. So 0.30 would be second, and finally 0.33 would be third. Always make sure that you go ahead and write the order, the correct order, perfect, rather than just leaving it as a 1, 2, 3. Make sure you go ahead and write from least to greatest. That's what we're going to do today, least to greatest. Okay, looking at the second problem, 0.6, remember that's a repeating symbol above that 6, so it's going on forever. 0.67 and 0.66. So first step would be to line up those decimals. And when I have a repeating decimal like 0.6 repeating, I do want to make sure that I, instead of putting zeros here, because that is not what follows the 0.6. What follows the 0.6 is 6.6 repeating is more sixes. So in order to compare all of these, I'm going to put just maybe 2 and then my repeating sign. Now, I need to fill in some more placeholder zeros. So after 0.67, I want 1, 2, 3 digits. So I'm going to put that 0 to compare and then a 0 below. Now all of my decimals have 3 digits, so it's easier to compare. Looking at my tens place, they're all 6s, so that's not really any help. Looking at my hundredths place, I have a 6, and a 7, okay? So based off of that, you can tell that your middle one is the largest because that 7 is larger than both of the 6s. Now we need to figure out the placement for the first and second decimals. So I'm going to go ahead and move to my thousandths place. So the 2 that I'm comparing are the top 0.666 and 0.660. So the 0 is smaller. So my 0.660 comes first, and my 0.6 repeating comes second. So when I go to write all of those, this is what it's going to look like. And my third one. Go ahead and stack your decimals. Make sure you write it out on the side of your paper. 1, 2. And again, I have some placeholder zeros to fill in because I have 3 digits here and only 1 and 2 on my first decimal. So I'm going to add 2 placeholder zeros there and 1 there. Okay, starting with my tens place, I have a 2, a 0, and a 0. My 2 is the largest, so that's going to be my largest decimal. And now I only need to figure out the first and second again. So after my tens place, I'm going to move to my hundreds place. And 1 is smaller than 2, so 1 is going to come first and 2 second. Go ahead and write that out. And voila, you are done. So what I want you to do is number 4, 5, and 6 require you to use an inequality symbol to decide which decimal is larger. Remember, just because it has more numbers doesn't mean it's larger. Start with the tenths place, move to the hundredths place after that when you are comparing. And then 7, 8, and 9, I would like to see them in least to greatest order. Once you are done with those 6 problems, you will see the stop sign. Please stop, raise your hand, and have myself or someone else, another teacher in the room, check your work. If we say you are all good to go, you may move on to the back side. You may pause the video now. Next up is converting fractions into decimals so that we can compare and see which decimal is the smallest and which one's the largest. In order to do that, we have to do long division, okay? So this is the part of the video that, depending on how you feel, how comfortable you are with long division, you might want to pause it more, you might want to rewind it again to hear the process, or you might fly through. It is completely up to how comfortable you are with this and how much work you did with it maybe in 6th grade. So we will start with 2/5. So 2/5 is my fraction. I want to figure out what 2/5 is as a decimal. When I do that, I'm going to remember that my numerator, which is the top number on the fraction, goes inside the house. That's why we say numerator in. And the denominator is going to go, which is the bottom number, the 5, is going to go outside of the house. So here's my little division house. And 2 is going to go inside the house, and 5 is going to go outside of the house. We're going to walk through the next 3 together, 10, 11, and 12. If you want to pause the video and double check your answers so you do it on your own, that's fine, but I will walk through these next 3. Make sure you're paying attention because you are going to have to do the next ones on your own. So, number 10, which is 2/3. I'm going to make my house, and the 2 goes inside, the numerator goes in, the denominator goes out. Alright, so 3 cannot go into 2. So we need to add my 0 and my decimal point right above the other one, and my 0 in front of the decimal point. Now I can ask myself, how many times does 3 go into 20? Okay, so if we think about our 3's times tables, if I did 3 times 6, that would be 18. And then if I did 3 times 7, that would be 21. So 21 is too large. It's bigger than 20. So 3 can go into 20 6 times. So I put my 6 up top to make this little house a little bit bigger. And I'm going to do 6 times 3. 6 times 3 is going to be 18, which we just talked about. And I subtract. Alright, so 20 minus 18 would give me 2. When you still have a remainder, remember what we do is we bring down our 0. 3 can go into 20. Again, same thing. 6 times. 6 times 3 is 18. We subtract, and you see, once this pattern happens, which it'll happen a lot, that we just keep on getting the same number, you can just put your repeating sign and call it a day. So 0.6 repeating is the same thing as 2/3. Those are equivalent. Next one, we have 5/8. So go ahead and put that into your house. Which one goes inside the house and which one goes outside of the house. Hopefully, you put 5 inside the house and 8 outside of the house. Can 8 go into 5? Nope, it's too big. So I add my 0 and my decimal right above, and my 0 above the 5. Now is the time that you have to think about your 8's tens tables. So if I said, what's 8 times 5? we would say, well, that's 40. Oh, 40. And I'm getting close to 50, so let's try 8 times 6. 8 times 6 is 48, and 8 times 7 is 56. So that one would be too big. The closest I'm going to get is 8 times 6. So 8 times 8 can go into 50 6 times. Then I'm going to multiply 8 times 6, and we already said that's 48. And I should get 2. Next step, bring down my 0. Now we'll say how many times can 8 go into 20? Well, 8 times 2 is 16. 8 times 3 is 24. So that's too big. Our answer would be 2 times. Anytime I'm saying how many times something can go into something, we put that number up top. So 8 can go into 20 2 times. 2 times 8 is 16. We subtract and get 4. Alright, so we got another 0 to bring down. 8 can go into 40. Alright, we already talked about this. 8 can go into 40 5 times, and that's an even. So 5 times 8 is 40. And now we have a remainder of 0. That's a 0, not 6. Okay, so 5/8 is 0.625. And the last one we're going to walk through together is 1/5. So we would say, how many times can 5 go into 1? None. It's too big. Add my decimal, add my 0, add my 0, add my decimal. Now ask yourself, how many times can 5 go into 10? 5 can go into 10. Well, we have 5 times 1 is 5, and 5 times 2 is 10. So 5 can go into 10 2 times. 2 times 5 is 10. Oh, lucky you. A remainder of 0. It's great when that happens. So 1/5 is 0.2. You're doing great. All right. What I want you to do is work on the next few problems using long division. When you see the stop sign, you may stop, raise your hand, and get your answers checked. All right, you may begin. All right, now if you need a little more help getting started on number 1 and 2 on the second decimal, converting the fraction to decimal sheet, I'm going to help you with number 1 and number 2. So starting with 3/4. Let's convert 3/4 into a decimal. So 3 needs to go inside the house, 4 needs to go outside. Numerator in, denominator out. First question would be, how many times can 4 go into 3? Well, 4 times 1 is 4, so we're already over 3. Got to add the decimal below, decimal right above, and our 2 zeros. Now you can say, how many times can 4 go into 30? Well, let's start doing our 4s. So let's start with 4 times 4. 4 times 4 is 16. 4 times 5 is 20. 4 times 6, 24. 4 times 7, 28. 4 times 8, 32. Too big. So I start with 4 times 7. So 4 can go into 30 7 times. 7 times 4, I'm going to write it directly underneath, is 28. I subtract, and I'm going to get 2. Bring down a 0 when you have a remainder. 4 can go into 20 right here 5 times. 5 times 4 is 20. We subtract and get 0. So 3/4 as a decimal is 0.75. And the second one, 3/5. 3 goes inside the house, and 5 goes outside of the house. 5 cannot go into 3. Add our decimal, decimal, and our zeros. Always follow that process. Now, how many times can 5 go into 30? Well, think 5, 10, 15, 20, 25, 30. That's 6 times. So 6 times 5 is 30. If I subtract, I get 0. 3/5 is 0.6. And you're done with the first 2. Go ahead and try to finish up the next 8.